Hello everyone! Today we are going to demonstrate a recharge process of an automotive air conditioning unit with hydrocarbon based refrigerant ECO-Freeze ECO134. ECO-Freeze ECO134 was our first choice by several reasons. It is natural, ecologically safe hydrocarbon mixture, and it is direct substitute for the most common, however banned, HFC refrigerant R134A, which is used in our current system. And as soon as we are intended to use existing equipment without any change, following the existing temperature levels and capacity requirements of air conditioning system is mandatory. As a substitute for R134A, ECO134 refrigerant has many advantages. The main are lower energy consumption, reduced operating costs, long service life due to lower operating pressures, and lower refrigerant charge by almost 2.5 times. On this pressure temperature chart, we can see the comparison of HFC refrigerants with ECO134. The concentration of ECO134 components was chosen in such a way as to correspond to the existing pressure temperature levels of the R134A refrigerant. Servicing any refrigeration system will require, in most cases, the following equipment, which includes torches, manifold set, vacuum pump, oxygen-free dry nitrogen, scale, micron gauge, pinch-off tool, and temporary line taps. However, servicing refrigeration system with flammable refrigerants will require additional tools, such as safety placard, refrigerant recovery station, and gas leak detector. So here is our vehicle and all the necessary tools we need right now. The air conditioning system uses R134A as a refrigerant, which according to MAC directive of EU F-gas regulation is prohibited from 2011 in new types of cars and vans and in all new cars and vans produced from 2017. And we are going to replace it with environmentally safe alternative ECO-Freeze ECO134. First stage is the recovery of the existing refrigerant. First of all, we need to connect the manifold set to the air conditioning system. After connecting the hoses to manifold set, we need to ensure that all valves are closed and connect the special quarter-inch adjustable quick couplers to high and low pressure sides of the automotive air conditioning system. Also, we need to connect the service hose from manifold set to the refrigerant recovery station. All hoses are specifically colored. Red and blue corresponds for high and low pressure sides and yellow is the service hose. The refrigerant recovery station we are using is specifically developed for operating with flammable refrigerants. It uses oil-free compressor to avoid contact with refrigerant and has all the built-in necessary precautions. It has two recovery modes and self-purge function after recovery process is completed. The amount of existing refrigerant is about 500 grams. Before recharging, we are going to use the scales and weigh the full can of the refrigerant to compare it later after recharge process is completed. The weight of the refrigerant can is about 655 grams, including the tap valve. After evacuating the existing refrigerant, we will recharge the system. The recharging process begins with fastening the tap valve to the refrigerant can. The tap valve should be fully opened before fastening in order to avoid accidental piercing of the refrigerant can. After that, we must connect service hose of the manifold set to the refrigerant can. We must fasten it tightly and check once again the high and low pressure side valves of the manifold set. They should be closed for now. The next step is piercing the refrigerant can. To do this, we must close the piercing tap valve on the can. After that, we slightly loose the service hose on the manifold side and release the existing air by opening, again slightly, the refrigerant can. Be aware doing it in closed room. The refrigerant is flammable and releasing it in confined space is against the safety rules. Recharging procedure begins with opening both high and low pressure side valves on the manifold set to evenly distribute refrigerant on both high and low pressure sides of the air conditioning system. Now, to get the refrigerant distribution to the whole system, we close the valves on the manifold set and turn on air conditioning system from the vehicle interior. From now we will operate with the low pressure side valve. The readings of manometers will indicate the air conditioning system start. Slight pressure drop will indicate that condenser fan is now working. After pressure drop, we must add small portions of the refrigerant to the system using only low pressure side valve on the manifold set. Sometime later, we can touch low pressure side valve on the air conditioning system for the vehicle. It is cold, but no condensate liquid yet appeared. Additionally, we can check the temperature level from the vehicle interior. According to manometer readings, we can add a little more refrigerant through low pressure side valve on manifold station. It is highly important to add refrigerant only to low pressure side of the vehicle refrigeration system and constantly check manometer readings. During the recharge process, we constantly check pressure and also checking low pressure side valve of the vehicle air conditioning system. Soon the pressure will stabilize and suction line valve on the vehicle refrigeration system will get colder. In some cases, it will get covered with water condensate. The recharge process is almost complete. Now the pressure is stabilized and we can close both service valves on the manifold set. Now we will once again weight the refrigerant can to see how much refrigerant did it took to fully charge the refrigeration system. According to scales, the weight is about 525 grams. So it took only 130 grams for the full charge of the air conditioning system. Thank you for watching and feel free to contact us.